Hey guys, I'm just going to walk you guys through the calibration of the unit. So when the unit arrives, it should look like this. Focus. There we go. My unit has the power LED removed so it doesn't shine a red light when it's in normal operation. It only sends it when you're updating the calibration values or the using stats mode. My mount's also larger than the mount you'll have. You'll have a slimmer mount unless you have a screen protector like I do, in which case you might have a bigger one. So I'm going to put the unit on the TV and we're going to get the calibration. So the unit sits up here for now on the top left. We may support the top right later, and we're going to plug that in. Now we're going to switch over to capturing on the computer display here so that we can see the settings better. So let's launch the program up. I'm going to launch the Linux version of the program. You'll be running the Windows version probably. The Windows version can take a little while to start because it has to unpack all the stuff. So then we're going to open up the IR settings dialog here and the TV settings dialog after. So the first thing you'll want to do is connect to the emitter. On Linux, it has a value like this. On Windows, it'll have a COM value. It'll try to give you the value it thinks it is, but if you have more than one serial device on your computer, you may need to check the value under the hardware manager, I guess. So once connected, you'll want to verify that you have the right IR protocol for your glasses. I'm using the Panasonic custom glasses, so I have a value of 6 here. The values will be changing during calibration are the frame delay, which is when it turns on, how long it waits after detecting a new frame on the screen before sending an open shutter glasses signal to the glasses. Frame duration is how long it waits after sending the open signal to the glasses before sending the closed signal to the glasses. And we're going to adjust those during calibration. The other values you may need to change that aren't part of the calibration, but you may need to change them to get a good result, are the block signal detection delay, which is how long to wait after detecting a new frame on the screen before the unit will be attempting to detect another new frame on the display. If you're using an LCD display with an LED backlight which has pulse width modulation, you may need to increase this value to be closer to the equivalent of the frame rate in microseconds, so something like 8,000, 8,100, something like that. The other value you may need to adjust is the min threshold value to activate. This is used to stop the unit turning on when there's no video on the display that uses the trigger boxes, and also to avoid the unit turning on just from ambient lighting in the room. So I have a value of 10 here because I use the unit in a darker room, but if your room's lighter, you may need to use a higher value here. But if you use a higher value, just be aware that the signal to noise ratio of the signal from the display and the ambient light may cause the unit to trigger incorrectly by mistriggering when it thinks there's a trigger signal from the display when there isn't. The detection threshold is a value between 1 and 255. So 128 is about 50%, and that is the value, the intensity of the light necessary before it detects it as a trigger from a new frame on the display. The other values you don't need to worry about because they're sort of beta testing values. So next we're going to open the TV settings display dialog here. So you'll want to change the resolution to match the resolution of your display. You'll probably want to have your display at 1080p. You'll also want to make sure that your display has BFI enabled. So you'll want to go under Game Optimizer, and you'll want to make sure that you're at 120 Hertz. Variable refresh rate is off, low latency mode's off, and that OLED Motion Pro is high. So you can see here mine's high. Anyways, so, we can't see that because that was on the TV. So let me swap over so you can see that 1 second. So you'll want to go to, the TV, and you'll want to go to Settings, Game Optimizer, if you're using an LG display, and you'll just want to make sure it's 120 Hertz, and that low latency is off, VRR is off, and that OLED Motion Pro is on high down here. Okay, So back to the in-screen display. So once you've got the resolution set, you'll want to set the display size. So I have mine as 55 because it's a 55-inch TV. This will help adjust the trigger boxes to match where they are roughly on the unit based on your display size. White box brightness lets you increase or decrease the brightness of the trigger boxes so that if you're concerned about burn-in, you can lower it if you are running in a dark room where you don't need to worry about ambient light triggering it incorrectly. These vertical position and horizontal spacing values will be adjusting during calibration, so you'll have some idea what they mean when we get to that. So now we're going to open up the calibration video. So we open a video for playback here. Oh, I forgot to say, before you open the video for playback, you'll want to make sure that the calibration mode box is checked here. So open a video for playback, and we're going to select a video from the video folder. We're going to use the black left, white right calibration video here. And you'll see here it says right eye on the right side, so the right side should have white light. So, and black should be on the left side. So we're going to open that up here, and we're going to switch to the TV mode before we do that. So let's switch over to the TV, and we're going to open this up. So the video should open. It'll flicker a fair bit because my computer's recording a video, so the CPU is pretty busy, but on your computer, once you've put it in full screen mode with F11 or clicking the full screen box, the flickering should decrease because the CPU will be focusing on playing the video back. So now we're going to walk through the calibration steps here. So the first step is to align the unit horizontally on the TV. So you'll see there's a vertical white line here, and there'll be a little bump on the bottom of the unit. You want the bump to line up with that white line. And doing that, you'll see that the flickering got significantly better when I did that because there is it's not mistriggering anymore on the left or right eyes. The next thing you'll want to do is align the trigger boxes vertically with the sensors on the back of the unit, and that can be done using the Y and H buttons on the keyboard. So pressing H will lower them down. As you can see, they've lowered down now. Pressing Y will make them higher. I'm going to lower them down here so you can see the boxes to get a better understanding for what the next calibration procedure does. So the next option is for increasing or decreasing the spacing between the trigger boxes, and that can be done using the U and J keys. So pressing J will increase the spacing, and U will decrease the spacing. And you want to have them basically lined up with the sensors on the back of the unit, so you can do that. And then when you're done, just make sure that the boxes are back up properly vertically aligned based on the bump on the side of the unit there. And then also make sure that the horizontal alignment is right if you change the spacing of them. Okay, so now that we've done that, we're going to move on to the frame delay and the frame duration calibration process. So basically what you want to do is turn your glasses on, and you'll see, looking through the glasses, you should roughly see that the right eye has a white background, the left eye has a black background, but you may notice there's a bit of vignetting at the top of the screen and the bottom of the screen. It looks like it's black at the top and the bottom of the screen on the right eye, and there may be white at the top and the bottom of the screen on the left eye. This is from ghosting, or it's from vignetting if you're triggering too late and your frame duration is too small. But I'll just show you how to change it. So if you have, for example, black at the top of the screen, you're going to want to decrease your frame delay. If you see black at the top of the screen on your right eye, you want to decrease your frame delay. So I'm going to increase my frame delay just to show you what it looks like when there's black there. So if I put the frame delay up by pressing K about 40 times, because it increases by 10 microseconds each time. So 1, 2, 3, 4. So I did about 60 times there. So you should now see some black at the top of the screen. Yeah, there's a bit of black there. And it will have also, now you'll notice there's no black at the bottom because it's scrolled it off the bottom. So you could decrease the frame duration until you saw black at the bottom if you were getting desynchronization issues. So if your frame duration is too long, and it can result in sometimes it being too long for the frame rate on the display. So if you get a lot of flickering, you may want to try decreasing the frame duration until the flickering disappears. But I'm going to go and put it back so you can see that there's no more black bar at the top. So if I press I to decrease the frame delay, I'm going to do it 60 times. You should see now that there is no black bar at the top. There's a little bit of a black bar at the bottom, which is back how it was when I started. So that's how you do the frame delay and frame duration. You can also hide this instruction box by pressing G. And if you can't get satisfactory results using the calibration, you may need to change the other settings that we talked about. So I'm going to hop back over to the laptop display here, and I'm just going to go over those settings again. So you may need to change the signal detection delay, block signal detection delay. You may need to change the min threshold value to activate, and you may need to change the detection threshold as well. And once you've got satisfactory results, you should go ahead and save your settings to the settings folder here, so that you can reload them later, and you can also test other values to see if they work any better. You should also save your settings for the TV or display as a display settings JSON file here. And you can also, it will save the settings, when you close the window, it'll save these settings to your default so that they'll be used as the default next time. For this one, you'll want to click Save Settings to EEPROM if you want them to be used later as your default. So that's how you do the calibration. So thanks for that. And I'm going to make another video about comparing different glasses now. So next up, I'm going to show some testing with different glasses. I'm going to use the setting profiles provided in the settings folder for all the tests. They'll all be tested with my LG C1 OLED TV. We're going to show any ghosting or crosstalk at the bottom and top of the screens, and also any vignetting. There are some profiles that are good for reducing vignetting, and other profiles are good for reducing crosstalk, at least on this LG C1 OLED. For other displays, there may be, we'll try to put together some other profiles that'll be better optimized for them that will also reduce any ghosting or crosstalk. Specifically for the Panasonic glasses, I want to show a comparison of how it handles duplicate frames. And when I say duplicate frames, I mean when the computer isn't able to do the software page flipping fast enough and it sends out 2 left eye images or 2 right eye images in a row, the glasses need to resynchronize, and you'll be able to see in slow motion that the stock firmware for the Panasonic glasses can take anywhere from 3 to 5 frames before it can resynchronize, whereas on my custom firmware it will resynchronize instantaneously, and there are no desynchronized frames displayed to the wrong eyes. In the case of multiple dropped frames or duplicate frames where it shows, for example, 3 left eyes in a row or 4 left eyes in a row, sometimes it'll show one of the images to the right eye, but it will keep the left eye open all the time, and you'll be able to see that from the slow motion imagery. But there may be ways to improve the firmware too in the future, so I'll look into that further. Anyways, so thanks a lot for watching this video, and I hope you were able to learn how the system works a little bit, and yeah, thanks. Panasonic Gen 2 glasses stock firmware. Okay. Testing duplicate frame 1. Duplicate frames 2. Duplicate frames 3. Panasonic Gen 2 glasses custom firmware. Testing duplicate frames 1. Duplicate frames 2. Duplicate frames 3. Sony TDG BR100 glasses. Testing duplicate frames 1. Sony TDG BR750 glasses. Duplicate frame test 1. .3D Vision Gen 1 glasses. Duplicate frame test 1.